I would like to give the floor now to Pálma Szolnoki from the Zero Carbon Hub. And let me introduce her very briefly. Pálma is an economist with 20 years of experience in the energy sector. She serves as the lead expert on energy communities at the Zero Carbon Hub, where she has authored numerous research and policy papers on this subject. Over the past 3 years, she has actively supported the development of energy communities in Hungary. So, Pálma, the floor is yours.
Thank you for the introduction. So as we only have 15 minutes, I just jump right to the presentation. So a few words about Zero Carbon Hub. We were funded 4 years ago here at BME, and it is an organizational unit of FIAC, actually. And our mission is to support the decarbonization process of the energy sector with interdisciplinary researches. So we have cooperations with the industry, with international players, and also we develop policy recommendations to the government. The research that I will present to you today, it was more than a 1-year research project. It was funded by the European Climate Foundation, and we were working on it in cooperation with the Smart Power Lab from BME. David Rice is also here, and he was the leading expert from Smart Power Lab in this project. He will give a presentation in this afternoon also. So the main question what we were investigating is whether energy communities could be called upon and could be used in favor of the grid. What's the problem with the grid? So we have this decarbonization target. So we want to fully decarbonize for the energy sector, the electricity sector as well. And actually, we are progressing in it pretty much. So we already have 8 gigawatts of PVs in the Hungarian electricity grid. And out of this 8 gigawatts, 3 gigawatt is the small-scale, household-scale PV plant that are connected to the low-voltage section. So what's the problem? We are progressing in this decarbonization path, but we are really a long way to the full decarbonization. But by today, we have already reached a saturation of the grid. So, for example, in the low voltage section, there are the distribution system operators are starting to close this grid segment. What do we mean by closing? Actually, they say that if in this low voltage section the voltage breaches a limit, then no further PVs can be connected to this low voltage section with an injection potential. So basically, no PVs can be further added. But if we cannot add further PVs, then how can we go ahead with our decarbonization process? So actually, what we need is that with the conventional solutions, we have reached our limits. So we need new innovative ways for integrating further PVs into the system. And our question was whether including energy communities in solving the grid integration problems could be one of these innovative solutions or not. So first what we did is that we made an EU-wide survey on the energy communities and what kind of regulatory environment are they in. So energy communities were first introduced in the clean energy package of the EU. And many countries, many member states already have a supportive environment for energy communities. So there are, of course, the direct support schemes, which in Hungary we also had some earlier. But there are also supporting measures within the electricity system. And one of the main supporting measures is providing a discount on the grid tariff for the shared energy. So when a producer shares its production to a consumer within the energy community, then on this shared part of the energy, the grid fee can be reduced. And many member states already apply this kind of regulation, this kind of an incentive. And the main logic, how they apply it, is that if the smaller the grid section that is involved in this energy sharing, the larger is the discount. Actually, in Hungary, we do not have such or any kind of incentives within the electricity system for energy communities. And what does the regulation say? What's the regulatory background? Last summer came out the new energy regulatory package. It's called EMD, Electricity Market Design. And actually it says that on the shared part of the electricity that you can consume, a cost-reflective network charge has to be applied. What do we mean by cost reflectiveness? Well, that's a really good question, and this is what we were looking for in our research. So if you look at, again, the clean energy package, it says that for energy sharing, there should be a cost-benefit analysis be performed by the competent national regulatory authority. So actually, in all the member states, the regulatory authority should deliver such a cost-benefit analysis. Well, most of the member states have not done it. We have only found one such a cost-benefit analysis, but it was only concentrating on the peak consumption reduction potential of energy communities, not PV integration potentials. And of course, also the Hungarian regulatory authority hasn't also performed this cost-benefit analysis. So we, in this research, deliver this cost-benefit analysis. How did we start? Well, first, the Smart Power Lab has built two low-voltage network models, one representing a typical Hungarian low-voltage section, and the other one, because this was an international study and we wanted our results to be applicable to other member states as well. So that we also included an international SIGRE benchmark models, which reflects the residential feeder in the European low voltage system. So the Smart Power Lab has built these two grid models. And then we defined together the base case. So the base case on these low voltage models is that we applied increased the PVs that were on the model on the grid up to the level where it reached the level of saturation, which is based on what the distribution system operator, how it defines these predefined criteria where they lock actually this grid. So when it reaches this saturation level, this is the base case. So we have already a lot of PVs integrated into that grid, and no further PVs could be further added according to the current regulation. And then we have defined 16 different scenarios, most of them energy community activity scenarios, and looked at whether if we apply this energy community action to this saturated grid, could the PV, could further PVs be added to the grid, and what network effect will it have? And besides the energy community activity scenarios, we also, and Smart Power Lab also analyzed the more conventional DSO site tools for solving the PV integration problem. So the OLTC, on-load tap changers application, and the more traditional line replacement. And so these were the different scenarios, and the three main KPIs that we looked at to evaluate the different energy community activities effect was, of course, whether the PV hosting capacity could be increased. And the other two KPIs were about the underlying network. So how does the underlying network is affected with adding further PVs? And we had many results, as you could see. We had many. Excuse me, I want to go back. Okay. So we had many scenarios, so I cannot tell you all the results. If you are further interested, please contact us, and you can also find it in our webpage. So I will just show you one example, the example of storages. So what happens when there is a community storage in this low voltage grid section? So there is a central storage, and we apply it to this already saturated grid. Of course, what we see is that the PV hosting capacity can be increased, while, and this is very important, the load on the underlying grid can be decreased. So the pressure on the underlying grid sections can be decreased. And this is very important, this result, because actually if you look at the traditional grid DSO side measures, so the OLTC and the line replacement, these are good for increasing the PV integration capacity of the grid. However, they do not help in elevating the pressure on the underlying grid. So actually, community storage is a better solution if it's applied to the grid than the DSO side measures. And of course, we also analyzed what happens if there are, if the storage is not a central storage, but it is a decentralized storage, meaning that in each household you have the behind the meter storage. And the first analysis was whether these behind the meter storages are controlled in a way that it's operated on a community level optimization. And what the result was that actually if these decentralized storages are operated with a community level optimization, we have the same beneficial results as if it was a centralized storage. So actually what matters is not whether it is a centralized storage or a decentralized storage. What matters is how it is controlled. So whether with an individual or community level control. Because when we switched the control of these decentralized storages to an individual behind the meter control optimization, then what we found is that the network effects were a lot less beneficial. So less PV hosting capacity improvement was, and also the effect, the pressure on the underlying network was reduced with a less amount. So actually the optimization process, whether it is a community level or an individual level, is what really matters. But what do we see right now? Even though using and optimizing, for example, the storages on a community level is a lot more beneficial to the grid than having these optimized on an individual level, what we see right now in the Hungarian system and in all the systems in the EU is that if you have behind the meter storage and you optimize it on an individual level, then you do not have to pay grid fee. But if you would optimize it and use it on a community level, then you would have to pay the grid fee twice. So first when it goes to the storage, and then when the others or you consume it. So even though community level optimization is better for the grid, you have to pay twice the grid fee, while on the other hand, in case of individual level optimization, you do not pay any grid fees. So clearly there needs to be a change in mind, a change in the regulation system in order to bring these beneficial effects of community level energy systems to the grid. So first, what we really need to have is that the community level optimization should not be more costly than the individual level optimization. What does this lead to? We have to reduce the grid fee on the shared part to zero as well. But what happens if we reduce the grid fee on the shared part to zero? Well, this revenue is lost. So this is the cost of this regulation. So we had to also see what are the benefits. We had to quantify the benefits that this community level optimization could bring to the grid. So actually what we did is that we went over each scenario and quantified what benefit it could bring to the grid if energy communities would act this way and optimize on a community level. So we calculated PV integration benefits, calculated benefits due to the to the reduction of the network losses, because if consumers are supplied from the neighbors, the network losses can be reduced. And also the benefits due to the reduction of peak consumption, which I have just said in the beginning in another member state where there was this, they delivered this cost-benefit analysis. Well, actually, they only calculated this benefit part, so that energy communities actually can really help in reducing peak consumption and therefore avoiding further investments into the grid. So we made many calculations, and actually the result was that the benefits are high, but not as high that these benefits could all pay up to the cost that it would cost that if we reduced the grid fee on the shared part to zero, this cost would emerge. So actually, it does not justify, the benefits do not justify reducing the grid fee to zero on the shared part. It justifies only part of it. So what can we do? Actually, community level optimization will only be incentivized if the grid fee on the shared part is zero. So we need to rethink the whole tariff system, and we need to design a new type of tariff system that, this is my last. So we need to define a new tariff system that will handle this problem. So actually, what we, and as I have showed you in the beginning, in many member states, they already make some kind of tariff reduction on the shared part, but that's not enough, because still, if you have some tariff on the shared part, then still individual level optimization would be more beneficial. So what we say is that we have to change this thinking about making a tariff reduction. We have to have a new tariff system where on the shared part you have zero tariff, while you have a totally different fixed part. So this fixed part would be higher, but it would also consider the benefits that this energy sharing activity could bring forward. So it has to be designed in a way that it also takes into account this cost-benefit analysis. Okay, I will stop here. We have many other results. So if you are interested, please contact us and look at our website. Thank you.